Hey guys, welcome to Unit 5. We're going to be covering global climate change, and I just wanted to make sure that we took a moment to go over really what's happening with it and kind of what is ultimately causing it, and that would be greenhouse gases. So a lot of people get these two terms confused, and that would be climate change and global warming, and a lot of scientists, and not so much scientists, but mostly media outlets kind of use these words interchangeably. And so we have climate change, which is referring to a change in temperatures. And what that ultimately means is that some areas are going up, some areas are going down, but if we refer to it as climate change, we're referring to an overall major change in the global climate patterns. In terms of global warming, we're usually just referring to the fact that temperatures on the Earth have seen an overall increase over time. So we've already talked a little bit about the greenhouse gases, and we did a lab that attempted to kind of show a little bit more about greenhouse gases and how carbon dioxide actually can act as a greenhouse gas. So greenhouse gas, what that basically means is that as the sunlight is essentially coming in, it's going to hit this molecule. In this case, we're generally referring to the carbon dioxide molecule, and as you guys know, I have to draw it correctly because I teach chemistry, but pink, okay. And then what happens is some of this light that actually passes through the atmosphere as it's attempting to leave the atmosphere is kind of reflected down. Also, the carbon dioxide itself will release a little bit of heat energy as it's struck with this light. And so ultimately what we see here is that the light and the heat is actually being kept in the planet rather than being able to escape after it hits the planet. So that's what we mean when we're referring to the heat trapping ability right here. And so carbon dioxide, CO2, has a relatively low heat trapping ability. So in general, when we think about it, it's not individually that bad. It's just that there's a lot of it. Okay, so the relative abundance, yes, you'll see down here, is less than 1% of our atmosphere. However, it is actually going to have a pretty significant effect. So, yeah, so it does have the ability to trap heat, and at a high concentration, it can be an issue. You guys saw in the video that we watched that it talked about methane, and methane is CH4. It's a natural gas. Well, it is natural gas. And it actually has a significantly higher heat trapping ability than carbon dioxide does. Luckily, there's not that much of it in the atmosphere. However, we already saw in the video that methane hydrates, or kind of frozen methane locked away in ice and underground, is being released through the heating of the surface. And so we are starting to see, in general, an overall rise in the concentration of methane, essentially. The last one that I put on here are CFCs. These are chlorofluorocarbons. These are generally known for being the molecules that affect the ozone layer, but they also have a really, really good ability to trap heat on the planet. Luckily, there's not very many of them in the atmosphere. The other issue to mention here with carbon dioxide is not only is it really high in abundance, but it sticks around in the atmosphere for a very long time. And so it is actually a big issue because of the fact that it sticks around for so long. The last thing that is on this paper, or excuse me, on this slide, is talking about how water vapor, which is of course H2O, water vapor actually is also a really good greenhouse gas. However, it's a natural one, so we don't really worry about it too much because it's something that cycles on its own, and it's not something that we're having a significant effect on. So here you have the ability to see the greenhouse effect, and so looking just at the left-hand side, we see that the natural greenhouse effect is actually showing that solar radiation goes in, it reflects back, some of it escapes to space, but the greenhouse gas layer that's in our atmosphere radiates a lot of it back down, and so we keep some of that heat in the planet. Okay, so it's good to keep some of the heat. So that's a really good point to make, is that without this part right here, then we would die, because we have to have some heat able to stay in the planet. There's plenty of planets that don't have atmospheres that get solar radiation and get enough solar radiation, but the problem is that that radiation reflects back off, and as it reflects back off, it just passes all out to space, so none of it stays. So we would not be able to survive in this, in a situation where we didn't have greenhouse gases. Now, on the right-hand side, we see what is a human-enhanced version of the greenhouse effect. There is no denying that we are releasing carbon dioxide. There is no denying that we're releasing methane. There is no denying that we are releasing nitrous oxide, which comes from the burning of gasoline in cars. So there is no denying that the greenhouse gases on the planet are increasing. And what we're seeing is that because of that layer increasing, it's actually radiating more heat to the planet. And so what that's causing is ultimately a rise in temperature. And so we're seeing that because it's radiating that heat back down to the planet, not very much of it is able to actually escape into space. Now, a really good example of what happens if you let this continue would be our neighbor, Venus. And Venus, while it's wonderful, is not livable because exactly what's going on right here, the greenhouse effect got so significant and so major that it was heat was unable to actually radiate back into space, so it passes through and it stays down there. So that's why the surface of Venus is the hottest planet in the solar system. So kind of gives us an idea of what could happen to Earth if we aren't careful with allowing this to get kind of out of control. And so right now we're seeing that by pumping this into the atmosphere and pumping this into the atmosphere and pumping that into the atmosphere, we're seeing a rise in temperature, which is in effect releasing more methane. And so we're starting to see this kind of positive loop, which is a little frightening. Overall, what we're seeing is that because of the fact that global surface temperatures are increasing, we're starting to see a lot of things happening. One of them is that precipitation and wind patterns are changing because we're actually seeing a shift in the jet stream. And so, going across the United States, the jet stream is a upper level current that generally, would flow like so. And what's happening now is that actually it's flowing significantly more kind of windy. And so we're starting to see areas that hadn't got very cold air. If you see here, if the current's blowing in that direction, okay, and down here would essentially be warm air, and up here would be cold coming from Canada and whatnot, then we're seeing areas of the country that are actually receiving more cold air than previously known, and then areas of the country that are staying warmer in the winter than previous situations. So, that's the idea with global climate change, is that some people are saying, oh, well, my area is getting colder. Yeah, because the jet stream has massively adjusted its path. That's not normal. So we can't argue that there's not something happening. And so that's one of the things that comes out of this change in precipitation, or excuse me, change in surface temperature. So we're leading to a change in the jet stream. Also, we're seeing more significant storms. They're more severe in terms of hurricanes as well as thunderstorms and others. And we're starting to see them in areas where we weren't previously seeing them. So hurricanes are actually making it all the way to the American Northeast, whereas previously they weren't able to. And then we're seeing major extremes in temperature. So like I said over here, we're starting to see some areas that are significantly colder than they used to be and areas that are hotter than they used to be. All of that is a kind of a result of ultimately the rise in temperatures across the planet. Thermal expansion of seawater. As the temperatures rise, ice caps are melting. But that's actually not the biggest impact on the rise of the ocean. The biggest impact is the thermal expansion. When you heat up water, the particles start to spread out a little bit, and as they do, the water expands. And so what's happening is that our oceans are actually expanding, and so we're starting to see the sea levels rise because of the expansion of the seawater. Additionally, of course, melting of ice caps causes a rise in the sea level, but also significantly causes problems with salinity. So it changes the salinity, reduces the salinity, and causes it to be more less dense, because it has less salt in it, which means that it doesn't sink like it's supposed to in certain areas of the planet. So this graph just kind of shows you that we are seeing a rise in temperatures across the planet, and consequently we are also seeing a rise in carbon dioxide, methane, and other chemicals, nitrous oxide included, across the planet. So this first graph is a great example of showing how carbon dioxide and methane almost mirror exactly the temperatures on the surface of the planet, and so both of those are going up, and we're starting to see a rise in temperature as well. So over here I have a couple questions. related to carbon dioxide, because carbon dioxide is our number one most closely monitored greenhouse gas, because we know it is probably the most significant component of the waste from our burning of fossil fuels. And so in this particular diagram, we get to see data from Mauna Loa, which is on the Big Island of Hawaii. And the reason that Mauna Loa is chosen is because it is one of the highest mountains on Earth. And so you're able to actually get a carbon dioxide rating that is beyond the actual cars, on the road. So you're not going to have that kind of day-to-day change as a car drives by. So at a high enough altitude, you can get a really good reading on what the overall carbon dioxide on the planet's like. And so what we see is that, it kind of is zigzagging annually. It rises in the spring, it dips in the fall. And so the question I put over here is, what causes the seasonal fluctuations in carbon dioxide in the atmosphere? Well, what's happening in the spring? Think about it. Okay. Hopefully you mentioned something about temperatures rising. Hopefully you mentioned something about trees coming out of hibernation and starting to have leaves again. And so photosynthesis goes up. So photosynthesis is going to rise right around this location, around April and May, etc. And so you're going to start to see a decline in carbon dioxide. And then it rises again in the winter because, the trees go dormant. And so that's kind of the reason for that. Most of the trees on the planet are located in the northern hemisphere, so the carbon dioxide on the planet fluctuates based on the spring, which is in the northern hemisphere, not the spring in the southern hemisphere. Changes in climate can affect life in a lot of different ways, but just wanted to kind of cover a couple of the quick ones because they will relate to an activity we're going to do in class next time. So changes in temperature ultimately can reduce the range for certain types of plants and animals. So what we can see is that if the temperature starts rising, then areas where this organism once was able to survive will not necessarily be viable anymore, and so the organism will either have to move or shift its range to include the new location where that temperature is the most likely temperature. Precipitation is also an issue. So if precipitation in an area goes down, then the plants that live there are not going to be able to survive as significantly, and you'll learn a little bit more in biology about ecology and how you have that kind of ricochet effect where if the plants go down, then all of a sudden the animals that eat on the plants die, and then the ones that eat those animals die, and then so you start to see this kind of like domino effect rather going across. And then changes in temperature and precipitation ultimately can change the biome that's actually located in that area. So we're already starting to see certain areas that used to be temperate dry forests turning into tropical deserts because of a reduction in precipitation and increase in temperature. There's a lot of ways that humans can be affected. I just wanted to hit on two of them. One of them specifically for humans in coastal areas, which obviously doesn't affect us directly here in Colorado, but we do see that across the board there is a massive percentage of humans that live along the oceans and along rivers and lakes and things, because those were the sources of water. Oceans maybe not so much, but the others, those were the only sources of water that were available. And so people colonized areas where water was prevalent. And so we see a lot of people living in those areas in major cities that are technically below the level of what we believe to be our new sea level coming soon. And so humans that live in those areas may actually die in major storms or be forced to evacuate due to loss of essentially habitat. So their homes may become inundated and they won't be able to actually survive in those areas. Temperatures are also already getting to a point where we're starting to see heat waves that are above livable ranges for humans. Yes, we do also have a temperature range that we can exist in like any other organism. So we have to be above a certain temperature and below a certain temperature. And certain areas of the planet are already seeing prolonged changes in a direction where it becomes too warm for humans to actually survive in those areas. So we're already starting to see these things, and it's something definitely to consider for the future. So starting in our next class period, what we're going to do is actually analyze a little bit of data from, I compile the data and then analyze the data from trees or pollen in a certain area to kind of be able to trace back a little bit about what happened with the climate over time. So that should be our next thing. So make sure you have these notes ready and write down any questions you have about them that you'd like to clarify, and I will see you next class.